Okay, number 7, it says Janet worked her addition problems by placing partial sums as shown. So what's going on here is we're adding up the ones only and writing that sum down, adding up the tens position, writing that sum down, and notice they scoot over to start in the tens place, and then they're adding up the hundreds positions and writing those numbers down. And then finally they will just add up down the columns. So we want to determine the partial sums. We're going to do the same thing here. So if we add 6 and 9, we get 15. Then if we add 5 and 7, we'll get 12 for our next partial sum. And then if we add the hundreds place 6 and 7, we get 13. And then once we add those partial sums, we'll just add right down the columns. So 1 up front, the next 2, 1 and 3 will give us 4. The next 2, 1 and 3 will give us 3. And then the last column is 5. Okay, now it says explain why this algorithm works. Determine the partial sums and work the provided problem. So we're going to do it again. We're going to add 8 and 4, we get 12. Now the reason why this works is because we're keeping everything lined up in its place value. So 8 and 4 give us 12. We put the 2 in the ones place and we put the 1 in the tens place. Then when we add up the tens place, we start in the tens place and then we carry over to the hundreds. So we get 4 plus 8 is 12 again. And then the last one, 2 and 7, give us 9. Okay, so if we add up down the columns, 9 and 1 give us 10. And then we add up to 1 and 2, we get 3. And then our last digit is a 2. There's only 1 in the ones place. Okay, so now it says explain why this algorithm works. The sum of any 3 two-digit numbers formed from 2 three-digit numbers is always equal to the sum of those 2 three-digit numbers. It's a mouthful. The placement of the partial sums under their add-ins accounts for the place value. That looks to be pretty much what we did. Okay, none of the partial sums were found by adding 2 of the same number, and then finding one partial sum at a time eliminates the possibilities of intermediate mistakes. Okay, so what we were actually doing, we were adding the placement of the partial sums under the add-ins. So this is the explanation that's going to explain why this algorithm works.